Given what is the operation of this voltage commutated chopper or voltage commutation circuit, how the main thyristor will be turned off by using the circuit. Okay, that I already explained. And based on this, I list out some points I already given. What the peak current through the main thyristor, what the peak current to the auxiliary thyristor, what the peak current through the diode, what the peak instantaneous voltage across the load. That is nothing but peak inverse voltage across freewheeling diode. Now, based on this operation, I want to draw some waveforms. Then based on that waveforms also, I will write some analysis also. That formula is also important for any competitive point of view. Okay. Can you draw the waveforms? Yes, this over. Yes. Parallelly draw the waveforms. That this is a triggering pulse applied to main thyristor. And this is triggering pulse applied to auxiliary thyristor. And this is load current. With the assumption of we are supplying the constant current to the load. Parallelly draw the waveforms. Don't wait. Okay. And this is IC waveform. Current through the capacitor. This IC. Take this is IT, VC, IFD, V0. Okay. One more waveform I'm adding here. This is T. That this is IZ, main thyristor triggering pulse. This is ICA, auxiliary thyristor triggering pulse. This is I0. This is IC. This is ITM. This capacitor current, this load current, this main thyristor current. Okay. Voltage across capacitor. This is IFD current. This is V0. Listen. Now we are giving the triggering pulses here. This main thyristor triggering pulse. That this is instant of t equal to 0. At t equal to 0, main thyristor is triggered. Once the main thyristor is triggered, it starts the conduction. We know that this is load current waveform. We are assuming that load current is constant. I0 remains constant. Throughout, we are supplying the constant current to the load. This I0 is constant. Okay. Whenever main thyristor is triggered, we know this capacitor is discharging. Main thyristor is triggered, initial state plus minus na capacitor is discharging. This circuit you know, already given this circuit. Same operation I am explaining using waveforms. So this already points over now. Yes. What is the circuit? This is supply voltage Vs. This is main thyristor. Capacitor. This auxiliary thyristor. Load. We are supplying the constant current to the load. This diode, inductor, freewheeling diode. This is main thyristor, auxiliary thyristor, diode, inductor, capacitor, plus minus Vs. And we are supplying the constant current to the load. I0 is constant. This unit. Okay. So main thyristor is triggered, capacitor is discharging. Capacitor is discharging means this in which circuit it is discharging? LC circuit. In LC circuit, what is the nature of the current? Sinusoidal oscillations. That I already given in the concept of LC circuit now. That's why the nature of the current is sinusoidal oscillation. In LC circuit, the nature of the current is sinusoidal oscillation. To draw this current. The current is reached to peak value, then it falls to 0. Okay. Then this is peak. What is peak value of current? Vs into square root of C by L. Okay. The nature of the current in LC circuit is sinusoidal oscillation. Now, whenever main thyristor is triggered, it also carries. But during capacitor is discharging, what the current through the main thyristor? Load current plus capacitor discharging current. The current through the main thyristor is capacitor discharge current and also load current. That's why you can get the wave shape like this. This is the main thyristor current. This peak current to the main thyristor is I naught plus Vs into square root of C by L. Then once capacitor is completely discharges, the only current through the main thyristor is load current. This load current is remains constant. Now it's supplying only which current? Load current when the capacitor is completely discharges. That means whenever this becomes negative, this becomes positive, then capacitor will not discharge, only main thyristor will supply which current? Load current. Okay. Now during this, what the voltage across the capacitor? Capacitor is discharging. That means the capacitor polarity is changing from plus Vs to minus Vs. Initially what the polarity? Plus minus Vs. Now it is changing to minus plus Vs. Understood? That means during this time, the capacitor is changing its polarity. That is, the capacitor is changing its polarity from minus Vs to plus Vs. Initially it is minus Vs, then it is changing to plus Vs. Changing its polarity from minus Vs to plus Vs. Now it is constant. Still up to triggering of auxiliary thyristor, it is constant. Let. Still it's applying the load current, constant load current. Now capacitor is discharging from minus Vs to plus Vs. Sorry, plus Vs to minus Vs. Now this voltage is plus minus Vs. Now at this instant we are trigger auxiliary thyristor. We are trigger auxiliary thyristor. This is the pulse applied to auxiliary thyristor. Then whenever auxiliary thyristor is triggered, then this reverse voltage will appear across the main thyristor. Then main thyristor will be turned off. When the main thyristor is turned off, then what is the current through the main thyristor? This falls to 0. This main thyristor current is 0. This main thyristor current falls to 0. Now, during this, capacitor is, whenever the auxiliary thyristor is triggered, now who supplies the current to the load? Auxiliary thyristor will supply the current to the load. During this, now again capacitor changing this polarity. How the capacitor changing its polarity? Minus plus Vs to plus minus Vs. That is minus Vs to plus Vs it is changing. Then it is changing minus Vs to plus Vs. minus Vs to plus Vs. This is minus Vs to plus Vs, it is changing. Then this remains constant. Okay, it is changing from minus Vs to plus Vs. Then again cycle will be repeated. Here at this instant auxiliary thyristor also turn off. At this instant auxiliary thyristor is also turn off. Now, when the auxiliary thyristor is also turn off, who supplies the current to the load to maintain the continuous current to the load? Who supplies the current to the load? Yes. When the auxiliary thyristor will turn off, who supplies the current to the load means then freewheeling diode will supply the current to the load. Freewheeling diode will supply the current to the load. This is the freewheeling diode current. Then freewheeling diode will supply the constant current. Yes. Sorry, here who supplies current to the load? Freewheeling diode will supply. Beyond this, freewheeling diode will supply the current to the load. Up to main thyristor will turn on. Freewheeling, I want freewheeling diode waveform. Sorry, you are drawing freewheeling diode. This is the freewheeling diode. Freewheeling diode will supply the current to the load. Up to main thyristor will turn on. Up to main thyristor is turn on. Freewheeling diode will supply the current to the load. Yes. Here main thyristor will turn on. Now here capacitor current is exist. During this time, capacitor current, capacitor is discharging. Capacitor is discharging through auxiliary thyristor. Auxiliary thyristor will supplying which current? Load current. That's why this is the, with respect to capacitor, it is this current. But this is capacitor discharging current. This is I0. Why taken this is negative? That means here which thyristor is triggered? Auxiliary thyristor. During the conduction of auxiliary thyristor, capacitor reversing its polarity. That's why taken capacitor current is nothing but auxiliary thyristor current. That is nothing but which current? Load current. Auxiliary thyristor which current it is supplying? Load current. That is which is supplying? Capacitor. That's why this is the capacitor current. Once the capacitor is discharging, means there is a current is exist. Now it is changing from minus Vs to plus Vs. Now what is this voltage? This voltage is minus Vs. This voltage is plus Vs. This current is freewheeling diode. Clear? Now what this current? This is also load current. This also load current remains constant. Here load current is present. Here load current is present. Here load current is present. In complete one cycle, we are supplying the load current. Now, if here main thyristor, auxiliary thyristor is turn off, auxiliary thyristor, sorry. Here main thyristor will turn off, auxiliary thyristor will supplying. Here auxiliary thyristor will turn off. Who supplies the current to the load? Freewheeling diode will supply the current to the load. Clear? Okay. Now, you want to draw the voltage across the load. Tell me. When the main thyristor is conducting, the voltage applied across the load is Vs. When the main thyristor is conducting, the voltage applied across the load is Vs. The voltage applied across the load is Vs. Here also main thyristor is conducting. The voltage applied across the load is Vs. That is the supply voltage. Up to this is Vs. But at the instant of triggering of auxiliary thyristor, it is 2 Vs. It is 2 Vs. Then slowly, at the instant only it is 3 Vs. But slowly capacitor is changing its polarity now. Then the load voltage is also slowly reducing. It goes to Vs. Then completely it falls to 0 whenever freewheeling diode is conducting. When the freewheeling diode is conducting, it falls to 0. Initially it is 2 Vs and it is slowly it is reducing and it falls to 0. Here freewheeling diode is conducting. When the freewheeling diode is conducting, what is the voltage across the load? 0. Now what this voltage? This voltage is 2 Vs. This is 2. But this is how much? Vs. Let this is the instant of t equal to 0. This is t naught instant. This is t1 instant. And this is t2 instant. And this is t3 instant. Okay. If I taken, this is t naught and this is t1 and this is t2 and this is t3 and so on. This is one time period of operation. This total is one time period of operation. Again cycle will be repeated. Okay. Again the voltage applied, the voltage across the capacitor is Vs. It comes to the first stage. Then we can trigger which thyristor? Main thyristor. Here we can apply the triggering pulse to the main thyristor. Once triggering pulse to the main thyristor is applied, then again the capacitor will current we can get. Then main thyristor will current we can get. But I am drawing the waveforms only for up to one time period only. Okay, clear? Concentrate. Whatever the operation is there, based on this operation only, I have drawn these waveforms. Then during this time, whatever this time is there, during this time, tell me, during this time, this is minus, this is plus, minus plus, a reverse voltage applied across the thyristor. During this time, a reverse voltage, minus plus is reverse voltage across the main thyristor. The time taken a reverse voltage applied across the main thyristor or main device is nothing but which time? Circuit turn off time. That's why this is the TC. It is TC means because of symmetrical, this time is also taken as a TC. Minus Vs to 0, whatever the time is taken, from 0 to Vs also same time is taken because of symmetrical. Then it is TC means actually it is the TC. But why I taken this is also TC? Because this time and this time is equal. That's why I taken this is also TC. The time taken a reverse voltage applied across the device is nothing but a circuit turn off time. During this time only a reverse voltage is applied across the main thyristor. Okay. Now see, from this I want to do some analysis. That is also important. Tell. Shall I write like this? The current through the capacitor IC equal to C into dV by dt. IC equal to C into dV by dt. What is the current through the capacitor during this time? I am defining this during this time. What is the current through the capacitor is nothing but I naught. Don't take any negative sign, no need of that one. I naught. C into, what is the change in voltage? dV by dt. During this time, minus Vs to 0. 0 minus Vs. That is Vs. Then what is that time? This time is Tc. Dt is nothing but a Tc time. Okay. Now, what is the, from this what is Tc equal to? Cvs by I naught. This time is called circuit turn off time. What is the circuit turn off time? Circuit turn off time equal to Cvs by I naught. This one formula you remember. Circuit turn off time equal to Cvs by I naught. Next. One more formula I am writing. Okay. I want to write average output voltage. Average output voltage. All this I am giving from waveforms only. Average output voltage. V naught equal to. This is during on time. Here main thyristor is conducting. This is taken as on time. During on time, up to this, what is the voltage? Vs. Vs into T on plus. This total is one time period. Now this is also average output voltage. What is the area under this curve? Half into 2 Vs into. This time is which time? Tc plus Tc. 2 Tc. By total time period is T. This is the average output voltage. Then shall we write like this? the average output voltage V naught equal to Vs into, take the Vs is common, T on plus 2 Tc by T. 2 Tc by T. Shall we write like this? Then Va naught equal to Vs into T on dash by T. Then D dash into Vs. This is the average output voltage in the case of voltage commutated chopper. What is here? T on dash equal to effective on period. Effective on period equal to T on plus 2 Tc. What is D dash equal to T on dash by T? That is called effective duty cycle. Effective duty cycle. Okay, this formula also. What is the average output voltage? D dash into Vs. What is D dash here? T on dash by T, where T on dash equal to effective on period, T on plus 2 Tc. Then T on dash by T. Okay, now one more formula. Listen please. In this circuit, how much time the main thyristor is on? The main thyristor will on up to the capacitor voltage changing from plus Vs to minus Vs. During that time only main thyristor will turn on. After changing from plus Vs to minus Vs, suddenly if auxiliary thyristor is triggered at that instant, main thyristor will be turned on. That's why the minimum on period of main thyristor is, during in this LC circuit, whenever the capacitor polarity changing from plus Vs to minus Vs, during that time only the main thyristor will on. That means during the conduction of current in the LC circuit, that is main thyristor will on. What is the on period of LC circuit? Pi root LC. There is no any initial voltage across the capacitor. There is no initial current in the inductor. I told already. What is the on period of LC circuit? Pi root LC. That means during that time only main thyristor will turn on state. That is the minimum on period of main thyristor. Minimum on period of main thyristor. On period of main thyristor. Minimum on period of main thyristor. This is how much? T on equal to pi root LC. During minimum this much of time it is on. Beyond that also it will on. Above this also it will on if you don't trigger auxiliary thyristor. If you trigger auxiliary thyristor, it will be turned on. That's why minimum on period is pi root LC. Before that it will not turn on. Understood? The minimum on period of main thyristor is pi root LC. Okay. Because during the conduction of LC circuit only main thyristor will on. Next, tell me. Once you know the minimum on period, then what is the minimum duty cycle? The minimum duty cycle equal to T on by T. T on by T. Then that is pi root LC by T, that equal to pi f root LC. This is the minimum duty cycle. Once you know the minimum duty cycle, then what is the minimum output voltage? V naught minima equal to alpha Mn into, this is the minimum output voltage equal to alpha Mn into Vs plus. But there is another voltage na, that is half into 2 Vs into 2 Tc by T. Then what is the minimum output voltage? The minimum output voltage equal to alpha Mn into Vs plus, this you simplify these two to cancel, then what you get? Yes, that is Vs into 2 Vs into Tc into F. 1 by T is written as F. Then from this, what is V naught minima? The minimum output voltage equal to, take Vs is common, alpha Mn plus 2F into Tc. 2F into Tc. This is the minimum output voltage. But simply remember, the minimum output voltage is this one. This one. This is the minimum duty cycle. This you remember. This is the minimum duty cycle. Yes. Tell. Then what is the maximum on time? What is the maximum on time? In the total time period, if you subtract this time, during this time circuit is not on state. In the total time period, this is, you subtract this one, remaining is the on time. That's why maximum on time is this completed. Yes, over, quick. Yes, maximum on time. Next, maximum on time is maximum on time. Maximum on time equal to T minus 2Tc. Then what is the maximum duty cycle? The maximum duty cycle, you take, instead of alpha, you take, duty cycle is denoted by either alpha or D. I am following D notation na, then you take D minima. This I am following D minima na. Yes, D minima Vs, D minima Vs, this is D minima. I am following D na, that's why you take D, no problem. D minima Vs. Wherever alpha is, I have taken D, duty cycle. Okay. Then D max equal to how much? D max equal to, D max is T minus 2Tc by, this is T. T minus 2Tc by T. Then what is the maximum output voltage? Maximum output voltage equal to D maxima into Vs plus D maxima into Vs plus then half into 2 Vs into 2 Tc by T. Okay, this is the maximum output voltage. If you simplify this one, what is V naught max equal to? V naught max equal to D maxima into Vs plus 2 cancel. Then what we get is 2 Vs FTC. FTC. V naught max. By simplifying this one, you can do that. This is maximum output voltage. Okay, this you know, quick. Based on the analysis of voltage commutated chopper. Okay, that you concentrate. So, tell me, what are the drawbacks of voltage commutated chopper? Drawbacks of voltage commutated chopper. What are the drawbacks of voltage commutated chopper? You tell me. Yes. One drawback is main thyristor carrying the high currents, because at the instant of main thyristor it carries load current, and main thyristor carrying the high currents means which increases the rating of the main thyristor. Main thyristor carrying the high currents. Main thyristor carrying the high currents. Carrying the high currents. Which increases rating and cost of the thyristor. which increases S. Rating and cost of the thyristor. Rating and cost of the thyristor. This is one drawback. The another drawback is peak inverse voltage is 2 Vs. Peak inverse voltage across freewheeling diode equal to 2 Vs. That is, peak instantaneous voltage across the load is also 2 Vs, which increases rating of the freewheeling diode. Third one. During operation of the circuit and switch arrangement like this, a starting circuit is required. It requires starting circuit. It requires a starting circuit. That is one more drawback. Fourth one. Listen please. The chopper cannot work under no load condition. Why? Because if load is not present, there is no path for change of polarity of capacitor from minus plus Vs to plus minus Vs. Then in the next circuit, for next cycle of operation, again it must get plus minus. How the capacitor is charging minus Vs to plus Vs? Through auxiliary thyristor and through load only, na? For next cycle, it must be plus minus. That's why to change from minus Vs to plus Vs, it must be load. That's why otherwise the operation will not start. That's why the chopper cannot work under no load condition. It cannot work under no load condition. Because there is no path to charge the capacitor from minus Vs to plus Vs. Next, fifth drawback. We know that what is V naught equal to D dash into Vs. What is D dash? T on dash by T. Then T on dash is greater than T on. This is a theoretical on time. This is a practical on time. Then what this one? V naught is, let this is average output voltage greater than theoretical value. Theoretical V naught. That is V naught equal to dVs that you calculated. Because without this commutation circuit, what is this chopper? Step down chopper. In step down chopper, what is V naught? dVs. But here what you are getting? By considering commutation circuit, what you are getting? D dash Vs. This is a practical case now, because we are also considering commutation circuit. That's why practical values are more than the theoretical values. Practical values are more than the theoretical values. Practical values are more than the theoretical values. This is one more drawback. Okay, practical values are more than the theoretical values. Now see the sixth drawback, sixth one. I'm writing sixth one. We know that what is V naught equal to? V naught equal to S T on by T on plus 2Tc into Vs. That is Vs by T into T on plus 2Tc. Therefore, V naught equal to, that is, before that I am writing T on dash equal to T on plus 2Tc. That means T on plus, what is Tc? CVs by I naught. If I naught is reduces, what is the T on dash? Increases. That means the on time is depends on the load parameters. In this chopper, the on time is depends on the load parameters. If low values of loads are connected, less load currents, the loads which take the less current. That means if low values of loads are connected, low load current, the loads which takes the less current, if the low values of loads are connected, then it takes the more on time. If it takes the more on time means the frequency of operation is reduced. That means at what frequency we are operating this chopper depends on the load parameters. This is one drawback. At what frequency the chopper is operated is limited by load. If you connect the low values of loads, then it takes the more time. If you connect the high values of the chopper which takes the high values of load current, then it takes less time, then frequency of operation is increased. This also one more drawback. Understood? If I naught is reduces, what the T on dash increases, what the frequency reduces. That's why the frequency of operation is limited by load parameters. Okay, these are all the drawbacks with respect to voltage commutated chopper. Okay, but only advantage of this chopper is it is a simple chopper circuit. One more point to remember. For example, if it is minus, it is plus. Whenever auxiliary thyristor will turn off, whenever auxiliary thyristor will turn on, main thyristor must be turn off. If this whatever the stored charge in the capacitor is there, that stored charge will not sufficient to turn off the main thyristor, then commutation will be failure. When the commutation will be failure means still main thyristor is conducting. Understand my concept what I am telling? Even though auxiliary thyristor is triggered, because of insufficient energy in the capacitor, that is not sufficient to turn off the main thyristor, then commutation will be failure. When the commutation is failure, still main thyristor is conducting and auxiliary thyristor is also conducting. Auxiliary thyristor will conducting. When the auxiliary thyristor is conducting means, then it becomes plus, this becomes minus. This becomes plus and this becomes minus. Okay. But auxiliary thyristor, this is plus and this is minus. Understand? But main thyristor is not turned off. Still main thyristor is conducting. For next cycle, if you want to make the turn off of this main thyristor means compulsory, we can switch off the supply. Again, we can start the circuit. The point I am telling here, if any commutation failure is there, even though auxiliary thyristor is triggered, if main thyristor is not turn off, for next cycle of operation also, you want to make the turn off the thyristor means, again you can start the circuit from initial itself. Again you can completely switch off the supply, then again you start the circuit. Okay, that operation is required if any commutation failure is there. Okay, all these points you remember with respect to what exactly voltage commutated chopper. It is also called impulse chopper. It is also called classical chopper, or it is also called it is also called parallel capacitor commutated chopper or parallel capacitor turn off chopper. Why it is called parallel capacitor turn off chopper? By applying the reverse voltage of capacitor across the main thyristor, then it will be turn off. Then it is nothing but a parallel capacitor commutator chopper. Okay, these waveforms you concentrate. Whatever the formulas I given, that you concentrate. Clear? Okay, that you know. Okay, in the next session, we will continue with another type of commutation, that is nothing but a class B commutation. Once I am teaching the class B commutation means indirectly we are studying the current commutated chopper or current commutation. Okay, the next session will continue.